This is Algebra 2 with Trig, 1B.5. We're going to talk about writing quadratic equations when we're given points. We're going to talk about vertex form. We know we're using vertex form because our picture, our information that it gives us, provides the vertex. So we're going to be talking about situations when we might want to write it as vertex form. So there's our equation written in vertex form. Now we're going to convert it so it works for these points that the parabola goes through. We're going to substitute our values of the vertex. Down here, our vertex is h, comma, k. The other point that they give us is x, comma, y. They could have given us any point. They happen to give us the y-intercept. It's irrelevant, doesn't matter. So we're going to substitute h and k in for our equation because we know what that is. But what don't I know? I don't know what the a value is. Well, you might be able to come here and notice what the parent function would be 1 over 1 up, but I'm going 1 over 2 up. 1 over 4 up should be the parent function, but I'm going 1 over 8 up. So I have a pretty good prediction on what my a is just by looking at my graph. But how can we calculate it? What's the math support to see that? So what we're going to do is plug in our x and the y and solve for a missing variable. When you write your final equation, you need to be sure to have an x and a y. So I showed you a really quick way to identify the a value. But that's not always reasonable. So sometimes a calculation is much more helpful. So y equals a, x minus h squared plus k. That's our vertex form because they give us the vertex. Our y value is 5. I don't know my a. My x value when my y value is 5 is 0. Minus my negative 2. So it's important to write down parentheses negative 2. Squared plus my k value of negative 3. Now we need to be able to calculate for a, solve for a. Well, we can simplify this a bit. This becomes a 0 plus 2 squared minus 3. Now, if we do 2 steps in 1 here, if we add the 3 to the other side, and this is going to be 2 squared. 2 squared is 4. So I kind of did 2 things at once. Now, a problem that happened on the past quiz is some people were subtracting the 4 to the other side. This is not a subtraction question. This is a times 4, or 4a if you like to write it in front. We're going to divide by 4. So a equals 2. That's what we noticed when we came over. We didn't go up 1, we went up 2. We didn't go up 4, we went up 8. We went up twice as much. The a value is 2. So my equation is 2 for the a, x plus 2 for the h, minus a negative is plus, squared minus 3. There's my equation that works for this parabola. We had to solve for a. So we plugged in the information we knew, and we calculated it. So when we come down to our next example, I notice my graph they give us but they don't give us a vertex down there. So we're not going to be able to use vertex form. But if I'm being observant enough, I notice that they do give us x-intercepts. So I'm going to use intercept form, and that's y equals a, x minus p, x minus q. So I'm going to substitute in my p and the q. The p value, I'm going to call it, being the one on the left, is -3. The q value is 2. And my x and y are my other random points. Just any point will do. Now if you look at this, determining over and up is a little harder to do. You don't quite know how far over one is and how far up you're going. So that's not a good method. So we really need to be able to calculate it now. So we're going to plug in our x and the y to our equation. And that's going to help us solve for a. And when we write our final answer, we need to remember to use x's and y's in the question. So you go ahead and try to write out your equation by plugging in your values and coming up with the a term. So now that you've tried, we're going to plug in our y equals a, x minus p, x minus q. I would suggest to write out your equation. We know the y value is -4. We do not know a. Our x value is -2. And our p value is minus a -3. The x value is -2. That doesn't change. You can write it twice. Minus your q value, which is 2. So -4 equals a. This is -2 plus 3, and this is -4. Well, that added together is 1. 1 times -4 is -4. It's not -4. It's -4. So I'm going to divide by my -4, and that gives me an a value of 1. So my final answer is y equals, I don't really need to write the 1, x plus 3, x minus 2. So we'll flip sides. Here are some other practice problems we can do. So you can pause the video, work these two out. Notice that these are x-intercepts. So we're going to be using the formula ax minus p, x minus q. And this one gives you the vertex. So we're going to write this one in vertex form, as so. So pause the video, work through those problems, see how you did. So we have our p and the q. I know my p value is -2, my q value is 1, my x and y. So my y is -4, my x is -1, minus a -2, my x was -1, minus 1. Now I have one equation with one unknown. That's -4, -1 plus 2, minus 2. So this adds to become 1, and 1 times -2 is -2. So again, that is not a minus 2. This is a times a negative 2. So we have to divide. So a equals 2. So I'm ready to write my equation. 2x plus 2x minus 1. Because my p is a negative 2, it looks like a plus 2, and because my q is a positive 1, it's x minus p, so, or q. X minus q, so it's x minus 1. This side is your vertex form. So we have 4 equals a, 0 minus 2 squared, plus 1. We subtract the 1 across. Square the negative 2 becomes 4. Divide, and this is 3/4. That's a crazy one. So y equals 3/4. X minus 2 squared plus 1. All right. So we wrote our equations that went through the provided points. We used vertex form because they gave us a vertex. Now, what if they give you points that are not necessarily the vertex, not necessarily the x-intercept? I don't know which form to use. I can't use vertex form, and I can't use intercept form, so maybe I can use a standard form. So there are multiple ways we can do this. One way we can do this is very quickly using our calculator. So we're going to use y equals a x squared plus bx plus c. And we're going to use our graphing calculator. Not my favorite thing to do, but it definitely works. I would suggest to do second plus 712. Be sure to clear it so all your lists are cleared out. All right, so what we're going to do is we're going to follow this pattern. There's a video here if you want to see another method, not another demonstration of using the TI-84. Or if you want to try a completely different, it's called Desmos. It's all on the computer. If you don't have a calculator at home, you could use Desmos to do the same type of thing. So here you are. We want to type in points. So to type in points, we need to go to stat. Stat is right underneath the delete button. There the stat is, right underneath the delete button. And you get this menu. And we want to go into edit for this menu. That's what they're telling us here. Put your list 1 for your x's, list 2 for your y's. So I have an x value of -2, 0, and 2. So those are my -2, 0, and 2 for L1. And my y values are -6, 6, and 2. If we got creative, we could talk about where these points fall on a graph of -2, -6, 0, 6, and 2, 2. Can you make a parabola out of that? Well, it definitely looks like the parabola would have to do something like so. It looks like my a is going to be negative, but let's find out. We're going to go back to stat. Now I'm going to arrow over to calc. There's the calc. I use my arrow button and go over to calc. I'm going to go down to number 5, which is quadratic regression. Quadratic regression. This is making an equation given data. Here's your data. What's the equation that's going to go through that? There's only one parabola that can go through those 3 points. Now, your screen might be a little bit different than this screen. It might be a little bit different. Are you putting your information into L1, your X's into L1, and your Y's into L2? Yes, you did. So we're just going to arrow down till we get to calculate and hit enter. And then magic happens, and we know that my A value is -2, which we weren't surprised about. We knew it had to open upside down. So my equation is -2x squared plus 2x plus 6. Now to write a question or equation for these points, again, we'll go to Stat, go to Edit. Now we got to get rid of these. To get rid of them, you can just hit Delete, or you can actually just type right over them. -7, -3, 5, -92, -12, -44. You go to Stat, arrow over to Calc, down to number 5, Quadratic Regression. We're looking for a quadratic equation that has this data. So we're -7, -92, -3, -12, 5, -44. So we're getting a parabola that comes in here. So again, we're expecting the A to be negative. Where your X values in list 1 and list 2 are just arrow down. Your screen might be a little bit different than this, but it's pretty much asking you for the same information. Hit enter. So my A value is -2, my B value is 0, and my C value is 6. There you go. All right, our last one here. We have a table that shows the horizontal distance traveled by a baseball hit at various angles. Here's your angles, here's your distance. Create a scatter plot of the values in your calculator. What sign will the A value be? Find the quadratic model and answer a question. So what we're going to do is go to Stat and Edit. We're going to put those values in. So my X values are 10, 15, 24, 34, 45, 48, 58, 64. And we put in the numbers that correspond to those. 115.6, 157. I'll pause it now and I'll be all done. Okay, I now have it all typed in. If you don't have yours typed in, just pause it, get it typed in. All right, so for us to make a scatter plot, this is minorly cool. So for us to get a scatter plot, what we need to do is work with our window. So let's hit Window, which is the button here. And we need to be smart about where we're looking on our window. We have an X value that goes from about 10 up to 64. So I would suggest a minimum at 0, so that's always good to have the y-axis on the screen. And we need an X value that goes all the way up to that, and maybe a little bit extra. So 70 might be nice. Okay, we can count by tens if you want. Doesn't matter, that's irrelevant. So your y values, I often like to have a minimum at 0. And our highest point looks like 285, so let's say 300. If we go to graph, it doesn't have anything to graph. So we have to go to stat plot. It's right here above the y equals. Second stat plot. And we're going to turn the stat plot on. So we hit enter. We're going to turn it on. We're going to tell it to make a scatter plot. And we're going to use our values in list 1 and 2. And you can pick either shape that you like. Kind of fun. And when we hit graph, then we see it. So we made our scatter plot. It's kind of fun. Why would we use a quadratic regression for this equation? The points form a parabola. What sign is our A going to be? Well, it's opening downward, so the A is going to be negative. A is going to be less than 0. Graph opens down. This graph right here opens downwards. Find the quadratic model. So I already have my data in the stats. So if I go to stat and over to calc, we can do our quadratic regression. Number 5. And yes, those are the values we're using. So we hit enter, and there's my crazy equation. So I have y equals negative 0.177 x squared plus 14.651x minus 20.147. And if you would like, you could go to y equals. You could type that in. There are different ways to do this. Let's see if we can get this to work. I'm not sure this is going to work. Let me test it first. Okay, I think we're going to make this work. We're going to go to vars, which is right next to the clear. We're going to go down to statistics, over to equation, and we want the regression equation that we calculated. So we hit enter, and it types in all the numbers into y1. So when we hit graph, it's going to plot those out, and you can see that this parabola got super close to all of those points. Now what we want to know, the left field fence is 270 feet from home plate. At what angle to the nearest tenth of a degree does the ball have to be hit? So we want 270. So let's get to 270. So that's the two x values that represent the angle. So we're going to do second trace. We're going to look for the intersection of those two. Your first curve, it's a little hard to see right now, so maybe I need to make my window go up even higher for my y max. Okay. So second trace, we go to intersect. First curve, second curve. I did that kind of quick. So it's happening at 32.9, 92 degrees. And second trace, intersect. First curve, is that your first curve? Yes. Is that your second curve? Yes. And then you have to get closer to the other answer for you to get that result under guess. Guess matters with this operation. So 49.7. Those are the two angles that you would need to have so that the ball's going to reach that height. Good job.